got public service people in the area. I may have to interrupt for 2 minutes during our session if they ring on my doorbell.
Okay.
But other than that, we can proceed. They may not get to me until this afternoon. So, what do you got for me today?
All right. So the first one is 2x minus 3, the square root of 2x minus 3, equals 5.
Okay, how do we get to our finish line?
We take this, we square both sides.
Okay, it's a good first step. What's that give you?
Well, that gives me 2x minus 3 squared.
No, gives you 2x minus 3.
Oh, yeah,
In other words, whenever
back.
you square, that's the reason
and then
you're
25.
both sides, is to get rid of the radical sign.
Yeah, 25 on the right side.
Okay, next step.
Plus 3 on both sides. X equals 16. Oh, 14.
Okay, hold on. Before we go further, when you take a number like that and cut it in half, you just cut each digit in half.
Okay.
You don't have to memorize nothing. You just have to cut each digit in half. Now, it's not quite the same if I'm cutting that in half, because I don't cut that in half perfectly. But when you have an even first number and an even second number, and you're cutting it in half, like 86, you can just cut each one in half. That's the answer.
Okay.
Okay? What else?
So wait, that one was 14, right? There we go. The square root of 7 minus 3x equals 1.
Hold on. Sonny, come on. Sonny, hi. Just trying to get rid of my dogs out of my office. Sorry.
It's okay.
All right. So what's the next line?
Square both sides.
Keep going. In other words, when you're doing these on paper, you don't have to tell anybody what you're doing. You just need to write the next line.
Minus 7 on both sides.
No, hold on. That's the first line. What's line number 2?
Oh, 7 minus 3x equals 2. Or 1, I mean.
Okay. Now, which side are you going to put the x's on?
I'm going to leave them on the left side.
They have a negative sign in front of them.
Oh, okay. So let's subtract 1 on both sides and then add 3x on both sides.
That is the best way to think about it, because you avoid negative signs.
Yeah.
In other words, that's the key thing in determining which side you're going to put your x's on. Because you can put them on the left or the right. Put them on whichever side gives you a positive sign, plus or minus sign.
Yeah.
So x equal 2. Okay. What else?
All right. This one's the cube root of 3x minus 1 equals 2.
What are you going to do here as your first step?
Just cube both sides.
There you go. What's the next line?
Next line is 3x minus 1 equals 8.
Yeah. Let me tell you, these are good to know and memorize. Up through 5. You should know that's 4. You should know that's 8. You should know that's 16. That's 32. The reason you want to memorize them is so you don't have to go and when somebody says, what's 2 to the 5th, you don't have to go 2 times 2 times 2 times 2 times 2. It takes long. And these come up so frequently in math. They really do.
Mm-hmm.
Okay, so this becomes 3x equal 9, x equal 3. All right.
All right.
What else?
Next up, we have the, what do you call that? A
Absolute value
root?
sign?
It's a 4 root.
Oh, fourth root.
Fourth root x minus 7 equals 2.
All right, now before we take that first step, what's another way of writing the left side?
I'm not sure.
That's what fourth root means. It's just a fractional exponent. Okay? So to get rid of this exponent, we would have to exponentiate both sides by what?
4.
Uh-huh. And based on your rules of exponents, what does that become?
It just becomes 0.
Well, 1.
Yeah.
In other words, you're going to multiply the exponents. So you have 1/4 times 4, which is 1, which leaves what you wanted in the first place, is that.
Plus 7 on both sides.
All right.
All right, the next one is the square root of 6x minus 8 equals x.
Okay, good. Gonna get some quadratics here because these tend to work out a little differently. You end up with 2 answers for x.
Okay.
Next line.
6x minus 8 equals x squared.
Next line. You have a quadratic. How do you write it?
Negative x squared.
Make sure you always have a positive in front of the x squared term.
All right.
Means we have to move both of these terms to the other side.
Plus x equals x squared plus 6 or minus 6x plus 8.
Okay. Now what? How do you solve a quadratic where it's in standard format? In other words, we have everything on one side, 0 on the other.
And just factor it.
Okay. How's it factor?
X in each of the first.
Okay.
We're trying to find numbers that.
Hold on, you're forgetting step 2. Everybody forgets step 2. I don't understand it. I really don't. It's the most important step.
All right, so the first sign is a negative, so that means.
Hold on, you're supposed to figure out both signs. That's step 2. Figure out both signs.
Okay, so what does it mean if it's a positive and a negative sign in the quadratic?
Well, first of all, there's only one way to produce a plus 8. When you multiply 2 things together, when you FOIL them. And that's if both of them are either negative or both are positive. So what that plus in front of the 8 means is that the signs are the same. That's all it means. Now, how do you figure out whether it's negative negative or positive positive?
By the sign in front of the first sign, right?
The sign of the middle term. So in this case, what is it?
Positive.
What's the sign of the middle term?
Oh, negative.
Can you see why that will produce a plus 8? The last step of FOIL is multiplying those two constants together.
Yeah.
Negative times a negative produces a positive.
A positive.
Now you can apply your rules. What's the rule? Factors of 8 that do what?
Add to 6.
Yeah, add because that plus sign right there.
Yeah.
So they have to
4
add to
and
the
2.
number 6. So what are the two factors?
4 and 2.
And notice it doesn't matter whether I write 4 and 2 or 2 and 4. Same thing.
Yeah.
So now what are my answers?
X equals 4 and X equals 2.
Now let's check and make sure that both of them satisfy that equation. Because when you start seeing radical signs and equations, you very frequently have one of the answers that violates the domain, and you got to throw it out.
Okay.
An extraneous solution. So does 4 work?
Yeah.
Okay. Does 2 work?
Yeah.
Both of those solutions are good. However, as a forewarning to you, here's the 3 things you look for where you frequently produce extraneous solutions. Radical signs, absolute value signs, and logarithms. So whenever you have an equation involving one of those 3, be close on the lookout for solutions that are going to violate one of the domains. In other words, you can't take the square root of a negative number. And some of these absolute value problems just doesn't work with one of the answers. And same thing with logs. Okay? So those are the 3 things to look for. All right, what else do you got?
Square root of 4x plus 5 equals x.
Go from here.
Square both sides. 4x plus 5 equals x squared. Minus 4. Next line is 0 equals x squared minus 4x minus 5.
Next line.
Factor. X in the first spot for each of them, and then the sign's going to be negative.
How can you possibly produce that negative 5? It's always the first thing you have to ask yourself.
You have to have at least one positive.
You have to have exactly one positive and one negative. You can't have 2 positives, you can't have 2 negatives. You would never end up with a negative 5 if you did. So what that negative sign tells you is that one's plus, one's minus. Oh,
okay.
Now that kind of changes your rules. So now what are you looking for? What's the third step?
Find factors of the 5.
That.
Oh, subtract.
Okay, because of the negative sign in front of it.
To 4.
Perfect.
To negative 4.
No, not negative 4, just 4. It's better if you don't look at that sign for the moment, I think. I don't know. So factors of 5 that subtract to 4, that looks like 5 and 1.
Yeah.
Now we have to decide where the 5 goes, where the 1 goes. The larger factor
goes first, the 1 goes first, and then the 5 goes second.
Right, because the larger factor always goes with the sign of the middle term. So I know the 5 has to go there. 1 goes there. So my answers are
X equals -1 and X equals 5.
Okay. Let's check -1. Does that work?
Was this? It's the square. I think so.
No. Plug it in. What's the left side of the equation become?
It's like the square root of 1.
What's the square root of 1?
Isn't it like negative?
No,
Is it -1?
The square root of 1 is 1.
Okay, so that one doesn't work.
No, because 1 is not equal to -1. So that one we cross out. Now let's try the second one. Maybe they gave us one where neither one of them work. The second one worked. Does 5 work?
Yeah, second one works.
5 works. The square root of 25 is +5. Okay? So this was a good example because this showed us one where you end up with, and the reason you might wonder, how can we have a solution that's extraneous? It's because the rules of algebra don't say both of these have to be equal to 0. They say at least one of them has to be equal to 0.
Yeah.
Well, this one is not. It's this one over here that's equal to 0. Now, we always solve it by setting both of them equal to 0, solving it, and then testing our solutions. But if one of the solutions doesn't work, you have to throw it out. So this is a case where that's true. X equals 5 is the only solution.
All right. Next up, we have 2 times the square root of x plus 2, and then that's the end of the square root, minus 3 equals 7.
One step at a time. First step.
Add 3 on both sides.
Okay. Second step.
Divide both sides by 2.
Third step.
Square both sides.
Fourth step.
Subtract 2 from both sides.
So,
all right.
You usually want to get rid of any numbers that are being added or subtracted to your main thing here. And then you want to get rid of numbers that are multiplying that main thing, the main thing being the radical sign.
Yeah.
In other words, your first goal is to isolate that. Second goal is to get rid of the radical sign. You get that. Third goal, get rid of the +2. Okay.
Next up, we have 5 times the cube root of 4x minus 1, and then that's the end of the root, plus 2 equals 17.
Step by step, go through it.
Minus 2 on both sides. Divide by 5. Cube both sides.
Go ahead, give me the next line.
4x minus 1 equals 9.
Cube 3, don't square it.
Oh, cube 3.
You're cubing it.
3. Yeah, so 27.
Okay, next line.
Plus 1 on both sides.
Now, when you
Yep.
only get one solution, it's almost always valid. In fact, I've never seen a problem where it's not valid. If, however,
Okay.
somebody had a gun to your head and said that your life depends on this, I would plug it in and check and make sure. And you
Okay.
would find that, yes, the cube root of 27 plus 2 equals, or times 5 plus 2 equals 17. You'd have to check it from the start. But
All right.
you don't get extraneous solutions when you only get one solution. I'm not sure I've ever seen a problem like that. Where you get them is when you have two solutions, which you get when you end up with quadratics or cubics or quartics.
Okay. All right. So for the next one, it's the cube root of 8 minus 2x equals x minus 4.
Go.
Cube both sides.
That's how you have to do it. You can't write x cubed minus 4 cubed. It's not the same thing. You are indeed cubing both sides. So I have to cube x minus 4, that quantity. Okay? Now,
So that means,
how do we do that? Let's do that step by step, and then I can erase it. That's what that means right there. Okay, do this one times this one first.
x squared and then which one do I do next?
Well, FOIL that first one first. FOIL it fully. Are you familiar with the word
X
FOIL?
times negative 4x,
Okay.
negative 4x,
Okay, that's negative 8x, okay.
and then 16.
Notice that that 16 came only from that times that. That's why if you're factoring, if you're going in reverse, this plus sign tells you the two signs have to be the same. It's the only way you can get a plus sign.
And then just repeat that whole...
Well, you can't use the term FOIL, because FOIL doesn't work when you have a trinomial times a binomial. But what does work is every term by every term. So start with the term on the left, multiply it by both terms, and then go back. Just go left to right. Always. Don't jump around. Always go left to right. So what does that give you?
So x times x squared
Which is
just x squared.
it's x cubed.
X cubed.
You add the exponents. There's a hidden 1 right there. So x squared times x is x cubed. Keep going.
X times negative 8x is negative 8x squared.
Always start from the left and go to the right. Always. Otherwise, you'll end up doing it hodgepodge, and then you can never be sure that you've gotten every one done. In other words, finish your x squareds. What else does x squared have to be multiplied by?
Negative 4.
Now go to your negative 8x and start multiplying it.
Negative 8x squared. And then 28x.
Hold on, what's 8 times 4?
32.
Okay, is it plus or minus?
It's going to be plus because they're both the negatives that are multiplying.
Okay, you're done with the 8x's. Now go to the 16.
16x.
Hold on, let me write this just a little differently. And this is not a bad way to do it. Put it under that one. because you're going to end up having to add all these together.
Yeah.
And then what's the last one?
Negative 64.
Notice again, that number always comes from that last one times that last one. So when I'm looking at it in reverse, I know that the signs have to be opposite. Okay. Now, if we combine all of them, we get that. Now, you haven't learned how to factor cubics. They haven't taught you how to do it yet. So we're kind of at a point here where we can't solve the problem now. But let's go back up to this row right there. Okay? Instead of doing what I did, which was expand the right side of the equation, it's a better thing to do.
I'm not sure.
Take the cube root. Well, hold on a second. When I expanded that, now we were doing it the right way. I just got confused for a moment. Do you remember what the answer was? It was x cubed. See, we had minus 8x times, so it must have been, all right, let me do it again. X cubed minus 8x plus 16 times x minus 4 gave us x cubed. We got minus 8x squared and minus 4x squared. So we got minus 12x squared, and we got 16x plus 32x. There. Okay, here was my problem. I forgot this part over here. Now, what's the next step? Treat it like a quadratic.
You want to get everything on one side.
Yeah, and 0 on the other. So, I'm going to write this 0 there. I've only got one x cubed term. I only got one x squared term. But I got a negative 2x that needs to be brought over. What's that give me?
So 50x
plus 50x
minus 72.
And we still have a cubic that's extremely difficult to solve. So I guess my question would be, why are they giving you this problem? Why would they give you this problem? You can't even solve it by grouping. Have you ever solved cubics at all? Usually they teach you how to solve them by grouping.
Not really.
Okay, well you wouldn't be able to solve this by grouping anyway. Are they letting you use your calculators, your graphing calculators?
I'm assuming so, yeah.
Put that function in and see where the zeros are. That's about the only thing we can do at this point.
I'll just get to that later because this is the last one on the page. Okay. So
it was a bonus question.
So let's just move on.
Okay. I agree totally with you. Let's not spend our time on the problems that only 1 out of 10 students are going to get. And the only way to answer that would have been with your calculator. You just have to graph it and figure out where it crosses the x-axis. Those are your solutions.
All right, so now we have a practice exam thing.
Okay.
And the first question is simplify 6xy times 3xy in parentheses to the negative second power.
Like that?
Yes.
Okay. Couple ways we can do this. You sure it's exactly like this?
Yes.
Okay. There's actually many ways we can do it. The way I would suggest is that you get rid of the negative exponents immediately. How else can I write that right there?
The square root of negative 3xy?
Oh, that negative 2 means 1 over 3xy squared. That's what it means.
Okay.
Okay. Now I'm going to multiply all of that by 6xy, so we'll put the 6xy in the numerator. So this is another way to write it. That's all I've done.
Okay.
And the reason I've done it is because it simplifies it when you can eliminate the negative exponents. Okay? And they no doubt are telling you that they do not want the answer to have negative exponents in it either.
Okay.
So, what's the next law of exponents that we can use here? Let's go ahead and expand the bottom. What do you get when you expand the bottom?
How would I expand the bottom?
Square that denominator. What do you get when you square 3xy squared? Eliminate the parentheses, in other words.
9xy?
No, it's 9x squared y squared. In other words, this square applies to every term. So you have to square every term. You got to square 3, you got to square x, and you got to square y.
Okay.
Okay. Now, simplify that, starting with the numbers, and then simplify x, and then simplify y. What does 6/9 simplify to?
1/3, 2/3.
What's x over x squared simplify to?
1/2.
No. Let's talk about this. When you are dividing, what are you doing with the exponents?
Dividing?
Subtracting. You're never doing with the exponents what you're doing with the base, no matter what you're doing. If you're multiplying, you are not multiplying the exponents, you're adding them. If you're dividing the base, you are subtracting the exponents. Just remember, you're never doing the same thing with the exponents as you are the base. So if I'm subtracting the exponents, what does that come out to be?
-1.
Now rewrite that with a positive exponent.
It's just x.
No, it's not just x. X would be x to the positive 1 power. What does x to the -1 mean?
X over
Means
1 over x.
over x to the positive 1. That's what it means.
Okay.
Well, notice I could have gotten there straight away. I had x over x squared. I could just cancel one of the x's, cancel that exponent, and I got 1 over x. So this is the far more direct way of getting there. So I know my answer has an x in the denominator. What about the y's? What's y over y squared?
Probably the same thing. It's just going to be 1 over y.
Yeah, so my y is in the denominator. And that's important because that's the kind of answer the teacher wants. The same exact answer is this. The problem with this answer up here is that it has negative exponents. And almost always they want you to eliminate the negative exponent. So, everybody has troubles with negative exponents. I'm not quite sure why. Tell me what that is right there. Let's just drill you a little bit on them. The reason everybody has troubles with them is because they look at that negative sign and they think it's got to be a negative number, and it never is.
Yeah.
So what is this really saying?
2 to the cube.
No.
2 cubed?
Nope. 1 over 2 cubed, which is a positive number, 1/8.
Oh, I see what you're saying, because it's a negative.
Is all you do with that negative, it's the easiest thing in the world, is all you do with that negative exponent is make it 1 over the number to the positive exponent. That's it. So what is this?
1 over 3 to the 4th power.
Okay. What is this?
1 over x to the x squared.
I think you got it. Next problem.
All right.
And one thing, let me add one further thing. Just as this, I'm taking it to the other side of the fraction bar. If I happen to have something like this, where it's already in the denominator, well, I can take that to the other side of the fraction bar. See that?
Yeah.
It's a little different, but when you see a negative exponent, you just take it to the other side of the fraction bar and turn the exponent positive. That's the way to think about these negative exponents.
Okay.
All right.
All right, so for this one, we have 3x squared times, in parentheses, 5xy squared.
Where's
times, in
square?
parentheses.
Okay, like that?
No, it's outside of the parentheses on 5xy.
Okay.
And then there's another parentheses, xy. And then again, outside of the parentheses is going to be to the negative first power.
Okay.
And then the problem is to simplify.
Okay. So where do we start? What are we going to try to get rid of?
The exponents.
Well, that's good thing to think about. But the parentheses. Let's get rid of the parentheses. Let's get rid of the first parentheses. Square that. Every term under those parentheses has to be squared.
9x?
Squaring this one. Hold on. Let's talk about this one. You didn't put parentheses around the 3x, right?
No.
So that square only applies to the x. It does not apply to the 3.
Okay.
So that turns into 3x squared. However, there's parentheses around the 5xy, which means every term in there is being squared. So what do you get?
$5x squared.
Hold on.
Y squared.
Take it term by term. What's the number squared? What's 5 squared?
Oh, 25.
What's x squared?
X squared.
What's y squared?
Y squared.
Okay, I got rid of the first parentheses. If I want to get rid of the next parentheses, what can I do? Put it in the denominator. Just put it on the other side of the fraction bar.
Oh, yeah, okay.
Okay. Now, we're going to start there, and we're going to do each thing separately. We're going to have a fraction bar. Take the number. What's 3 times 25?
75.
Take the next variable, x. What is x squared times x squared all over x?
X cubed, or x to the 4th.
All over
Over
x,
x.
which is what? X to the, in other words, you're right, it's x to the 4th over x, but what does that simplify to?
X to the 4th?
Subtract your exponents. You got to know your rules of exponents.
Oh, x cubed.
Okay. And where is it, in the numerator or the denominator?
In the numerator.
Yeah, it came out to be a positive x cubed. That puts it in the numerator. Now, finally, do your y's. What's y squared divided by y?
Just y to the 1st power.
Where?
On the top.
Okay. There's your answer. I'm going to put a 1 under there, even though we don't generally write it like that. It's a better way to think about it when you're dealing with these things. Because you could have any term in the numerator or the denominator. It just turned out in this problem, everything ended up in the numerator, so we don't really need that one.
All right.
Okay.
I'm going to use the restroom really quick.
Okay.
I'll be right back.
Sounds good.
All right, I'm back.
All right, let's just review. There's nothing more important to you than knowing these rules of exponents. So what's the first one equal to?
-1, x minus 1.
X to the minus 1. Now if I said give it to me without a negative exponent, what is it?
1 over x to the 1st.
Good. Second one?
X squared.
Third one?
X minus 1.
third one is exponentiation. What's one level less than exponentiation? In other words, notice that when we're doing multiplication, we add the exponents, correct?
Correct.
Addition's one level less than multiplication. When we are doing division, we subtract the exponents. Subtraction is one level less than division. When we are doing exponentiation, what's one level less than exponentiation? Multiplication.
Okay.
So what is it? Multiply your two exponents.
6.
It's as simple as that. These are the only three rules. And they all have that property, or the exponents. First of all, you never do with the exponents like you're doing with the base. If you can remember that, you probably won't make a mistake. Ever. In other words, if you're multiplying the base, you're not multiplying the exponents.
Okay.
All right. What else you got?
Evaluate 36 over 49 in parentheses to the 1/2 power.
All right. That's the same way. What's 1/2 power mean? Fractional exponents mean what? It means square root.
The square root of... Oh.
Yeah, that's what that means. If it was the third root, you'd write it as 1/3 exponent. If it was the fifth root, you'd write it as exponent of 1/5. Okay? Now, there's another rule that says if I've got the square root of two things being divided, I can split that up into the top square root of the top divided by the square root of the bottom, like that.
Really?
So, how else can I write this?
Square root of 36 over the square root of 49.
Which is equal to what?
36 over 49?
What's the square root of 36?
6.
It's the square root of 49.
7.
6/7 is your answer.
Okay.
Okay, now let's just talk about that for a moment. One thing you really need to know is your perfect square numbers. You just can't get away without knowing them. When you're trying to simplify radicals, you really have to know them. But you want to memorize. When you look at the number 36, you want to know that that is 6 squared. And when somebody shows me 49, I know that's 7 squared. All the way up to 100. Those are the important ones.
Okay.
In other words, when you are looking for numbers that are the perfect square numbers, suppose I gave you what's the square root of 48. Can you simplify that? Well, the way to simplify it is you have to factor it into two numbers, one of which is a perfect square number. Okay, so I'm only looking for factors that are 4, 9, 16, 25, 36, and so forth. Well, 16 is a factor. 16 times 3 is 48. So that reduces to 4 root 3. That's how you reduce and simplify radicals. But the key to simplifying all radicals is to know your perfect square numbers, because those are the only factors you're interested in. You don't care if 8 is a factor of 48. 8 times 6 doesn't help anything. I got to have one factor that is a perfect square number. All right, what else you got? Got about 10 minutes.
Evaluate negative 243 in parentheses to the 1/5 power.
All right, when you see a problem like this where you're not supposed to use your calculator, and on this one you're not, know that your answer is going to be a small whole number.
Okay.
Okay. Let's talk about taking odd roots of negative numbers, first of all. If I say, what's the square roots? If I say, what's the cube root of 8? What is that? What number multiplied by itself 3 times equals 8?
2.
What is the cube root of negative 8?
2.
Negative 2. Notice negative 2 times negative 2 times negative 2 is negative 8. You with me?
Yep.
If I say, what's the square root of 4? The square root. In other words, if I've got x squared equal 4, and I'm going to take the square root of both sides, what is my answer?
2.
It's actually plus or minus 2. In other words, when you're taking even number roots, your answer always begins with plus or minus. When you're taking odd number roots, your answer is going to be the same as the sign inside the radical. Not so with even number roots. With me on that?
Yes.
Okay, so this problem, we're taking a 5th root. We know the answer is going to be a small whole number. It's going to be either 2, 3, or 4. Which one do you think it is? If I told you that it's got to be 2, 3, or 4.
Probably 3.
Yeah. 3 times 3 times 3 times 3 is 81 times another 3 is 243. So 3 is the correct number. Now, is it plus or minus? Or both?
Plus, I would say plus minus.
No. It's an odd root. In other words, it's odd because the number 5 is odd. So when you take the odd root of a negative number, you always get a negative number, just like the cube root of negative 8 was negative 2.
Oh, okay.
Okay. Notice what this means. That means minus 3 times minus 3 times minus 3 times minus 3 times minus 3. Well, minus times minus makes plus, times another minus makes minus, times another minus makes plus, times another minus makes minus. So my final answer is negative, and then 3 times 3 times 3 times 3 times 3 is 243.
I see what you're saying.
So you can take odd roots of negative numbers. Now, let me ask you this. Now, hold on. I'm taking the square root of a negative number. What's that? In other words, this is an even root because it's a square root. 2 is an even number.
Negative 2.
You cannot take even roots of negative numbers.
So what would the answer be?
It's not doable.
Oh.
Once you learn imaginary numbers, the answer is 2i. But you haven't learned imaginary numbers yet. And they're imaginary not just in name only. They are actually imaginary numbers. They do not exist. Okay, we come up with them because it furthers more advanced math, but you cannot take the square root of an even number. You cannot take the fourth root of an even number. You cannot take the sixth root of an even number. You can, excuse me, what I meant to say is you cannot take the square root of a negative number. You cannot take the fourth root of a negative number. You cannot take the sixth root of a negative number.
Yeah.
You can take odd roots of all of those numbers. Odd roots you can take of positive or negative numbers, but even roots have to be of positive numbers.
Yeah.
All right. What else?
Right, next up, we have
Now, incidentally, let me just add one thing, because there's a terminology problem here.
okay.
That's equal to that.
Okay.
This is equal to that.
All right.
Understand the difference? When I use the radical sign, I am saying I want the plus answer. When I use the fractional exponent, I'm saying, okay, I have an equation that's x squared equals 4. The only way I can solve that is by taking the square root of both sides, and that's when I get my plus or minus 2 because it's an even root.
Okay.
Okay? All right, what else? Time for one.
The range of f of x equals the square root of 1/2 x minus 4 plus 1. And the plus 1 is outside of the square root.
All right. First of all, domain is easier to talk about than range. So let's make sure you understand domain.
Okay.
Over here on the right, what's the domain of x? Domain always means what are the possible values of x that can be under that radical. We just talked about you can't have negative numbers.
Isn't it like infinity?
No, x has to be greater than or equal to 0, always, whenever you have this function. In other words, you can take the square root of 0, that's 0, but you can't take the square root of -1, or -2, or -1/2, or any negative number. Okay? So this is domain right here. Range is what the y values, or the f of x. F of x is just another name for y. Okay?
Yeah.
So if x can only be positive, what about f of x? What can f of x be? It's got to be also positive.
Yeah.
Or 0. So in this particular function over here, f of x always has, there's no way f of x is ever negative, right? Substitute any positive number you want for x, and you get a positive. The square root of that positive number is a positive number. So there's no way you can ever get a negative f of x. Now, if we look at your problem, it's a little more complicated because they've complicated it up a little bit. But if we're looking for values of f of x, what is the smallest value of the thing that I just circled? Can it ever be negative?
1/2.
Nope. Can it ever be negative? Let's start there.
I don't know.
Over here, the range is always positive when you are taking the square root of something. But it can be 0. If I let x be 8, then 1/2 of 8 is 4. 4 minus 4 is 0. The square root of 0 is 0. So if I let what I've got circled here be the smallest it can possibly be, then f of x can be equal to 1. And this can be positive numbers also. So when I'm talking about the range of f of x, got to be greater than or equal to 1. Because the part that I have circled cannot be negative. It can only be 0 or higher.
Okay.
Okay? The key thing is domain. If you're looking at a graph, make your eyes go left and right. If you're looking at a graph and you're talking about range, make your eyes go up and down. That's the way it works. But if you're looking at it algebraically, you kind of have to do it the way we did it here.
Okay.
Okay? All right, Nathan, I will let you go, and I will talk to you on Wednesday.
All right. Sounds good.
Okay, bye-bye.
Bye.